how y'all doing?
Good, hello.
Oh, what's y'all's team number?
97 dog sign.
And where are y'all from?
We are from Turkey.
Turkey.
Yeah.
Would you like to tell me a bit about your robot?
Talk about robots?
Yes.
Yes, he wants to talk about.
Now the robot isn't here, so well, let me just explain. It's basically based on the WCP's robot design, competitive robot design. It can score coral, and in autonomous it can score 2 corals to either side. We can take the algae off from the reef and put it inside the processor as well.
Oh, that's amazing.
Do you want?
Oh, sure.
I think we should try.
Oh, it's really good.
Do you like it?
Yes.
I'm so happy.
I hope y'all do good at this competition.
What?
I hope y'all do good at this competition.
I hope. Thank you so much.
Thank you for your time. What's y'all's team number?
If your glasses do not
What?
have side shields,
And where are
they
y'all
are
from?
most definitely not safety glasses.
Would you like to tell me a bit about your robot and what it's built to do this season?
Okay. Yeah. So
And part
this robot,
request.
starting off, we have a ground
In a
intake
1
robot.
inch-
So this ground intake
1
goes
inch
to the
thick
ground and it takes
dual
coral. So it can intake from any configuration. So it
To
ensures that we have
Team
maximum
4786
reliability.
at pit G35, 1 inch thick dual lock.
You can see over here, we have
To Team 4786 at pit G35,
sorry, it's a really bad view.
35,
And then we have a coral end effector here.
and a
So
step
this is
stool
able
or
to
step
intake.
ladder
This is able to shoot
to
out
Team
of a coral.
1369
So it goes through our
at
intake,
pit
through our
E51.
transfer mechanism, into
A
this end
step
effector.
stool or a step
This
ladder
end effector, it dunks
to
coral. So if this is on a pivot, on an
1369
elevator, so it can rotate all the way around and dunk on any level.
Echo
So this is
51.
also able to do algae.
And
So what kind of coding went into
important
it?
announcements
Yeah,
here.
so for coding, we did a lot of like
If you are
automation.
a Dean's List
We had,
finalist,
first of all, this camera was
you
able to
can
detect
go
coral
down
on
to
the
the
ground,
pin
so
admin
we're
and
able to
Hall
auto
E.
intake coral.
Hall
That's
E is
one
on
thing.
the other end.
We also have
Dean's List
localization.
finalist and you have
So
not
we
done
have
so
3
already,
cameras on our
you can go
robot
down to
that
pit
detect vehicle
admin
tags.
in Hall
So those
E
are
and
able to
pick
tell
up your
robot where it is on the field. So yeah.
with your goat
Is there
ticket
anything else you'd like to add?
for lunch today.
For now, that's it.
All right,
For
thank you
your
for your time.
ceremony.
What's y'all's team number?
9312.
And where are y'all from?
I'll be in a Canton, Michigan.
So tell me a bit about your demo robot right here.
So this robot we use at our week 3, week 4, and week 6 competitions. It's an arm that can reach all 4 levels. L4, L3, L2, L1.
And so we have 6 packages from the bottom that are belted all the way up.
And everything's basically on a dead axle. And then this is our climber. We pull out, grab the
What's y'all's team number?
9301.
And where are y'all from?
Mexico, Chihuahua, Mexico.
All right. Tell me a bit about your robot. Like, for example, what sort of coding went into it?
Coding on one.
From coding, we got a Surf models MK41. So basically, the code we don't use a lot of things. It's just some algorithms to make the control of the Surf drive very smooth. That's all we do there. Then we have around here in the mechanism from the Algae, we have a true board just to, in case the motors fails with the encoder, the true board gets in the right position every time. Then with the climber and the intake, we just do ball dodge, raw ball dodge, and we use 2 cameras detecting air tags all the time.
Ah. Is there anything else you'd like to add?
No, that's everything.
All right. Gracias por tu tiempo.
De nada.
Any questions or?
Yes. How are y'all doing?
Yeah, good.
What team number are y'all?
8214.
And where are y'all from?
Sorry?
Where are y'all from?
China.
Oh, what part of China?
Northern. The southern, sorry.
Southern China.
Yeah, southern China.
So what was your robot built to do this season?
So we got several functions. So first we can do the portal for L4 to L2.
It is a
We can take the algae from the floor and the reef, and we can shoot it in the barge and the processor.
Nice. Is there anything else you'd like to add, like difficulties in building and coding?
Yeah, so like
I would like to mentioning our designs of the robots. So most of the robots used for the carbon fiber, and we also use a lot of 3D printed parts. Actually, can get it.
And where's the mentor?
Yeah. So you can see all the remaining fibers in our Odometry and the taking part here. And you can see the curved one. The curved one was only made by the carbon fiber. And also we use a lot of money to lose weight. Because although we use this text, but we'll still full weight. There are too many problems. Yeah.
Really? That's very interesting. The fact that you chose carbon fiber over something else like max composite or something.
Yeah, so first, the reason for choosing carbon fiber is first we got really many experiences for using it, so we know how to use it for make sure that it's functionable, but also we got lose weight. So make sure that it's not too brittle. Yeah.
Have you tried finding unimportant parts of the structure and making little holes in it to lessen the weight even more?
Yeah, of course. So you can see the curved parts, the curved catcher for the to get algae.
Yeah, I see all the holes on the side and everything. Alright, well thank you for your time. It was amazing talking to you.
Yeah, thanks.
We have a sticky adhesive here so we can grab the cage. It's called alien tape. Yeah.
Okay, is this out here on the surface carbon fiber or max composite?
Carbon fiber.
Carbon fiber.
So we have carbon fiber plates and carbon fiber tubing inside here.
Nice.
And a lot of 3D printed pieces.
Yeah, and everything is carbon fiber and 3D printed.
So, what about this robot made you switch your current one from it?
So we realized that a lot of robots here
Are able to score L4 and L3 really consistency.
Yeah. And so we want to complement those robots by being picked by them. So we chose to build an elevator that can do L2 and L1.
Can you do algae?
Yeah, we can do the process.
Is there anything else you'd like to add? Like any coding that went into it?
In-risk kinematics. I don't know, that's it. That's all I know.
Like schematics and all that? Alright, thank you for y'all's time. It was amazing talking to y'all. What's y'all's team number?
10291.
And where are y'all from?
Brazil.
Alright, so tell me a bit about your coding this year. Do you have a coder here?
Coder?
Yes.
Yes, we have.
Alright, so tell me a bit about the coding that went into the robot this year.
Oh, okay. We not build with the programmer. Você não consegue falar um pouco? No. Yes. Our programmer is not here. Yeah, sorry. I don't know what nothing about.
So, what is y'all's role on the team?
I am the pit crew. We are the pit presentator. Yes.
So, what's the hardest part about having to be a pit crew member?
Okay.
Is it having to deal with your robot's aggressiveness or something?
No, it's more the language. It's the language. It's the language. The many people who come and go from different groups and different anxiety.
Language barriers are really hard.
Yes.
I mean, I understand it because yesterday I was talking with a Turkish team and I just couldn't understand them.
Yes, me too. Come on another team from really different countries and have a really big language difference.
Well, that's one of the great parts about Worlds.
Yes, it's been amazing. It's really amazing. We know a lot about all the world now. Yes, but when we gonna speak, we forgot some words. So it's the big parts.
All right. Well, thank you for y'all's time.
You too.
All right. How y'all doing?
We're doing fine.
What's y'all's team number?
6429.
And where are y'all from?
Turkey.
All right. So tell me a bit about your goal with all these banners up here.
So our goal is to spread FIRST and STEM in our region, in Turkey, and we have done 60-70 projects this year just to spread engineering and STEM in our country. Because students, we have an disadvantageous region as in STEM because not every kid can reach STEAM curriculum or STEAM sub-branches, so we're trying to balance that out with our projects, and we have made 19 new ones just this year. There are not a lot of quality educational STEM, they don't like pay attention that much, so we try to reach many students as we can, like this socioeconomically disadvantaged students who are hearing impaired, or like girl students. That's our target audience.
So what's your goal for this year in robotics? What's your goal this year for robotics?
So we're hoping that we can do the best because now our robot is at its match right now, so our mechanical team is not here, but I hope we are in a good rank.
Alright, thank you for your time. Number?
9576.
And where are you from?
Loretto, Minnesota.
So tell me a bit about your robot this year.
So we pick up coral from the station like this. And we also do algae. We can pick it up from the reef and from the floor.
So what about coding? Like what language do you use?
Java.
And what was some challenges with coding?
Probably vision, trying to get the line lights to work and get pose estimation working, but we got it working.
What materials do you use?
We use a lot of aluminum, some polycarb, and then some 3D printed stuff.
Anything like max composite or carbon fiber?
No, we don't use any carbon fiber, just polycarb, 3D printed, some ABS. But other than that, it's just a lot of aluminum.
So how many years has this team been?
This is our second year.
Nice. Is there anything else you'd like to add?
I don't think so.
All right, thank you for your time. Yep. All right, what's y'all's team number?
8808.
And where are y'all from?
Lake Charles, Louisiana.
All right, so tell me a bit about your robot this year.
So, we decided after our first competition, a claw is great, but it's not fast. So, we decided to go with the ground intake. So, essentially, it folds down. We use these to index, and then these wheels also index due to their different consistencies. Do we have a coral?
So I've heard in your matches it does like a little ringing sound whenever it spins. Why is that?
So that is the gears.
Oh, it's the
They
gears.
have a little bit of
wiggle.
yeah, but nothing to affect us.
What about the coding that went into the robot?
Oh, Parker, that's you.
Our robot, what we decided is we wanted to automate as much as possible. So even in teleop, what we have is this queue system, so that I, as the co-pilot, I will press inputs as like left and then a level, so L1 or L2, and then that stores it in the code, and then all the driver has to do is press execute, and it will fully autonomously line itself up, drive up, and score and back off. So it's really a cycle of just inputting cues and then just intaking and scoring back and forth.
So, what coding language did you use? What coding language did you use?
We use Java.
JavaScript. Is there anything else you'd like to add about coding, like difficulties or difficulties building?
Really, I think we're just most proud of that queue system because the way that it stores it and we're able to execute it later, we think we really did a good job on that, and it's something that we've never really done before. So we think we did it pretty well.
And what were some difficulties whenever building?
Well, this year is our first year doing CAD, and it was a learning process, but it wasn't difficult.
Did you have to make a bomb before you got all your materials to build?
We were able to test a little bit. So for our original call, we were able to test that, and then we also tested a algae intake early on in the season.
But like for a full-on build, did you have to send in a parts list for your coach's order?
Yes, so we took the CAD files and we sent them off to a CNC shop. So they had all the parts CNC created for us. We were very thankful for them.
Is there anything else you'd like to add on?
Yeah.
All right, thank you for your time. What's y'all's team number?
We are team 7034 to be determined from Westland, Oregon.
All right, so tell me a bit about your robot this season.
Yeah, so we are a coral-focused robot. We have an elevator and then a compliant wheel end effector. And we our two-stage elevator allows us to go anywhere from L1 to L4 really quickly. We have it counterweighted with constant force springs that make it almost neutrally buoyant, so our motors have to do very little work to get it from top to bottom. And then we also have a deep climb. It has spring-loaded hooks that pass through the bars of the cage. And then it has this polycarb triangle to center it, and then this bar along with the back of the hooks bind it and allow us to lift.
Is there, if you could take this and explain more in detail about your robot, if you can just take this and explain.
I mean, that's all I got.
What about the coding that went into it?
Coding? We have 2 cameras that we use for vision. We do photon vision. All of our code is done in Java. We have a bunch of very cool autos. I'm not on software, but
who is on software?
No one currently here.
All right. Well, thank you for y'all's time in the interview.
Yeah, thank you.
What's y'all's team number?
1369.
And where are y'all from?
We're from Tampa, Florida.
So tell me a bit about your robot.
So our robot can do all types, like we could do coral, we could score algae into the net, and we could also do processor.
Can you climb?
No.
Do you have a ground intake?
Yeah. Yes.
Does your robot use any alternative materials besides steel or aluminum?
Yes.
Like?
Polycarb.
Are you want to restart?
Is there anything else you want to add on about your robot's design process?
Oh yeah, so we use an elevator. There's something wrong with it. But yeah, we have a custom elevator that we made ourselves. We use for alternative materials. We use PEGCF for the clamps. We also have PEGCF for our swerve drive covers, and it goes all over our bot.
What about the coding that went into it?
The coding, we use a wayfinder. I'm not too comfortable with the coding.
We use Path Planner for our auto planning, and then we just use Visual Studios for teleop code.
And what's your coding language?
Java.
Is there anything else you want to add on, like challenges with coding, like any challenges with geometry?
Yeah, we had a pretty hard time with tuning because we didn't have a field for auto, especially. So I mean, now that we have a field, those challenges are kind of resolved.
Well, that's really neat.
We also had like a bit of issues with auto align, so we worked on that a lot over the last couple of days. We can see right there we have it set up. That's where we've been working on auto align for a while. We had a couple teams help us out with that, so it should be perfected by today. So we're gonna see how it goes once we run auto.
I love her outfit.
Oh yeah, we actually have 2 of them. We have the little one and then we have a big one.
All right. Thank you for your time.
Yeah, for sure.
What's y'all's team number?
10079.
And where are y'all from?
The greater Seattle area.
All right, tell me a bit about y'all's robot.
Can you repeat the question?
What?
Can you repeat the question?
Tell me a bit about y'all's robot.
Oh yeah, definitely. So this is our rookie year, and we've built a lot of stuff on a robot. So first of all, we have swerve drivetrain, which took a long time to build. We also have these custom plates on it with some handles because, you know, carrying this robot is really heavy. Primary parts of our robot is the elevator and the coral outtake. So this guy is on the elevator and intakes the coral through this funnel over here and outtakes it. This thing holds the thing in place, and then when we go to L4, L3, or L2, we'll outtake the coral. You've got a little sensor to also keep it there.
Do you have any way to get algae off the reef?
Yeah, so right here is our arm, and this arm can take algae from the ground, can take algae from the lower leaf level and the higher leaf level, so it's pretty useful. And we can process as well.
What about in climb?
Unfortunately, our robot can't climb, but we have like a little prototype right over here. So, and it seems like we put a sticker on it too.
We bought it from Andy Mark.
Yeah, Andy Mark design.
Is there anything else you want to add on about the robot before I move on to coding?
Ooh, I don't know. shit? Anything to say?
No.
No. Okay.
All right, now for the coding part.
Yeah.
Do we have the coders here?
That's me too.
All right. So what coding language do you use first?
What coding? We use Java. Okay. Yeah, we use Java.
And what about any challenges that came with coding?
Overall, it's all a new experience since we're a rookie team, but we were helped out through Woodinville and Chill Out, all the Royal Robotics. They all helped us out whenever we had issues.
And what about odometry?
Odometry, we use the Limelight camera, so it updates the onboard odometry, and then we can use that to align to a apron tag.
Is there anything else you'd like to add?
Our program is pretty organized. We're really trying to be very sustainable in all aspects of our team. So programming, hardware, we take lots of notes, and we're really proud of it. So.
Nice. Well, I'm glad that in your rookie year you made it to Worlds. Congratulations.
Yeah, thank you so much.
All right, y'all have an amazing day. All right, what's y'all's team number?
10032.
And where are y'all from?
We're from Frisco, Texas.
So tell me a bit about your robot this season.
So our robot this season, yeah, I'm not the best person to ask.
Who is?
Yeah.
All right, 1 second. Let me fix this mic.
Hey, cut that clip out.
So, what was the hardest part about building your robot this season?
I'd probably say the hardest part building our robot is just the lack of experience we have, mainly because we are a rookie team. We're in the process of also trying to teach our new members how to do engineering skills as well as electrical skills, while also trying to build a competition-ready robot. Another probably struggle is probably funding, trying to just get the required materials and machinery that we need in order to complete the subsystems that we need to have on our
So what's going on with this arcade machine over here?
Yeah, so this arcade machine is something we called Algae Abyss. It's a game that we made modeled after the actual REEFSCAPE game. So the game is basically a 1v1 8-bit arcade game basically, with a red alliance and a blue alliance. You're running around the field using your joysticks to go and pick up algae, pressing the button once to intake. And then there's also some algae on the reef. So to go pick this up, you can just go to the base of the reef, press once again to intake those algae, and then to score, you just go to each robot will go to their respective barge, and they can double tap to shoot. So we use this arcade machine for a lot of our fundraising events, networking, as well as community outreach. We actually went to a local library, and just let a bunch of elementary schoolers, middle schoolers, FTC, and FLL team just play around with it, just have fun.
I see. So you basically made your own version of this year's game?
That's correct, yeah. And it's something we actually would like to do for years to come. Like every year make an 8-bit arcade game based on that year's.
It gives our programmers a bit of time to,
relax and have fun.
Yeah, exactly. Yeah. Relax and have fun before they need to start doing time to go trip or whatever.
It's currently we're having some issues with it, but we are working on fixing it.
Nice. Well, thank you for y'all's time.
Thank you.
Hope y'all do good this year. Good morning. What's y'all's team number?
4476.
And where are y'all from?
Kingston.
So tell me a bit about y'all's robot this year.
So this year is Alex. It's a 2-stage, continuous internally belted elevator. And we have a separate L1 mechanism. And it picks up the Oh, gross. So should I just do that, or
Just point out some of them.
Yeah, sure. So this is our manipulator here. It's dual purpose. Could you turn the robot off actually, so it can move a little more freely? Oh, it's over here. Yeah, of course. So this here is our manipulator. We have a coral go in through here, and then score out the other side. It's pass through, and then on the other side we have here this algae mechanism. We use these wheels with grip tape, and this just over here. You can score in the net by just throwing it, which is a pretty cool motion. We send our elevator part of the way up, and then we do sort of like an arc with the pivot, and send it out, and it throws.
Do you have a climber?
We don't have a climber.
So how did you design? What was the design process going into this, making all of this?
Yeah. Do you want to cover that?
first thing when the season comes out, we have a little worksheet that we go through that kind of goes through the strategy of the game, things like get points, what are fouls, stuff like that, just so everyone has a good understanding. Then we start creating a priority list that involves kind of everything from driving in a straight line forward to being able to score L1 on the reef. And we organize that in terms of, we'll do that for our first event, for our second event, for our third event, or we won't do that at all, stuff like that. And then once we have that priority list, we're able to start making archetypes. So these are pretty much basic line drawings that help us get geometry out for seeing how a mechanism might interact with certain things on the field. Last year I was seeing how a shooter might interact with the trap. This year it's seeing how a manipulator might interact with the reef. Once we've done that, we kind of have an archetype that we've chosen. We go into something called blocky CAD, where we kind of allow space for different mechanisms, see where they might move, in what ways they might pivot, stuff like that. After that, we go into high fidelity prototyping. So CADing parts that we CNC and then use to prototype, stuff like that. And then after that, we just do CAD. We model our whole robot in SolidWorks, and it helps us kind of understand how to manufacture it.
What about the coding that went into it?
I'll give that back to Matthew.
Sure. So just about the coding in general? Yeah. So we have a heavily automated robot this year. Our robot has one, what we call driver assist button, where they can just press one trigger on their joystick, and it does one of any number of possible autonomous actions. So for example, based off of this sensor here and the cameras, which we use for odometry by tracking April tags, the robot knows where it is and it knows what game pieces it's holding. Because it knows that, when you press the auto align button, or the driver assist button, I guess, it knows it can score coral if it's near the reef and it's holding coral. But if you're holding algae, for example, and you're near the net, it would instead go to the net and throw it into the net. So essentially we have one button which can handle all of the driver assist actions in one, depending on the context of the robot.
So basically, it's almost fully automated, only a little bit of driver input.
Sure, yeah, the driver's still responsible for getting around defense and for driving from point to point, but once they're at, like, say the human player station, they just press a button and it automatically lines up with the human player station and picks up.
What about your autonomous?
Sure, yeah. We have a 3-piece L4 auto, and so far we haven't missed a single piece at championship yet.
Is there anything else you want to add on about like difficulties with it?
Difficulties with the code, I guess. We spent a lot of time on our odometry and our cameras, and it's like an ongoing problem. You always need to be tuning and readjusting, and it's a lot of work to make sure that the filtering for April tags gets you a nice stable pose you can use no matter where you are in the field. And of course, it has to be resilient to different lighting conditions and all of that.
If you're a Dean's List finalist, you have not picked up your packet, head down.
I think you're my new favorite team.
Oh, really?
All right. Thank you for your time. All right. What's y'all's team number?
7028.
And where are y'all from?
St. Michael, Minnesota.
So tell me a bit about y'all's robot this year.
So we have, so we can intake coral through this, which we call the hopper, and then it goes onto this belt, and then it can either go out through here to go to level 1, or it can be taken in by the end effector and then scored on level 3 or 4. Yeah, those are hard stuff.
So your end effector also doubles as an algae?
Yep. Pick up algae off the reef.
So what is the end effector made out of? Max composite or carbon fiber?
Red max composite.
All right. What about the coating that went into it?
Coating. Yeah, they're asking about the coding. Yeah. Talk about the coding.
All right. What's the coding that went into y'all's robot this year?
What do you mean?
Like, first of all, what's some of the challenges you faced coding?
Do you want me to hold it?
Yes.
Do I put it on my shirt?
You can just hold it.
Okay. Do you want me to talk into it, or are you recording me? Okay, I'm sorry. Probably the largest challenges we face coding this year is getting to, the auto align to work with the reef, because what we do is we automatically align the robot to the reef for scoring, so our driver just holds the button and then it scores. And that's been probably the most difficult thing to get to work. We've had to do a lot of tuning, a lot of sitting in the shop and running it over and over again and making sure it's accurate. And we use a lot of different sensor data and camera data and stuff for that. So it's been fairly difficult, but it's definitely been very rewarding.
What about the coding language?
We code in Java.
All right, and is there anything else you'd like to add on about it?
I think one thing that we've done we do this every year, but it's just, I think, really helpful for programming. It's really fun too, is we have our LEDs back there. They light up a ton. There's like a ton of different states that they'll be in. So like if it's scoring a coral, it'll be in one way. If it's like intaking, it'll do something. If it's climbing, it'll like runs like a pattern, a rainbow pattern up. And it's just really helpful. We have, during our auto align, we have segments on it light up depending on like if we've met our rotation target or our distance target. And it's really helpful both for debugging and also for communicating with the driver and the drive coach and the human player.
And just for funsies.
Yeah, also it looks great. It looks very pretty.
Well, it was great talking to you.
Yeah, you too.